Hi all. In today's lesson, we are going to observe real image and virtual image using a convex lens. For that, I have taken a convex lens. It can act as a magnifying glass. When it produces a real image, it is a convex lens or converging lens. When it forms a virtual image, then it is known as magnifying glass. In this lesson, we are going to observe real image as well as virtual image using this convex lens or converging lens. Here, this lamp will act as an object and we are going to focus the image of that lamp on this wall. So this wall acts as a screen. So object, lens, screen. Distance between screen and lens is known as image distance. Distance between lens and the object is known as object distance. So first we are going to focus the image on this screen and we are going to measure the focal length of this lens. So before performing our experiment, let me tell you about the difference between real image and virtual image. Real image or images which can be focused on screen or wall or anywhere else. Focus on wall or project on wall or screen or anywhere. That type of images are known as real image. Repeating, the image which can be focused on a screen or wall or anywhere else is known as real image. Virtual image means the image which can't be focused. That type of image is known as virtual image. So, are you ready to observe? Let's start. The light, that is our object, is on and I am going to focus that object's image on this wall. Focusing means I am trying to focus. Here we go. Now I have focused a clear image on this wall, that is screen. Right. What is meant by focal length of this lens? Very simple. It is the distance or length between a focused image to the middle of the lens. That is focal length of this lens. Let's have a look at this image. Now you all are familiar. I have focused on the wall. So this image is a real image. You can observe it is upside down. In the object, I have pasted one green color label on the top there. But here we can see the green color label is in the down part. So easily we can see that it is upside down. So the property of this image is real, inverted, that is upside down, and smaller than the object. Right. When the object distance get less, then the image will be larger. Okay, let's observe. I am reducing the object distance, that is distance between the lens and the object. Here we go. Now you can see the real image inverted and larger than the previous image. So here the distance between object and the lens get smaller. Okay, now again we are going to reduce the distance and check there won't be any image formed on the wall. But still, here we can see one image if we go through this lens. That type of image is virtual image. At this instant, this lens acts as a magnifying glass. Magnifying glass means the image will be larger than the object. It can't be focused on any screen, so it is a virtual image, magnifying image, and upright image. Real image was upside down, that is inverted, but the property for magnifying glass image is virtual because can't be focused, upright, and larger than the object. I will take the camera and we can view through this magnifying glass how the image is. Now you can see the magnified image. You can see the difference, and it is upright, larger than the object, and it is called as virtual because can't be focused on any screen or wall. I have performed this experiment by switching on all the lights. Now I will switch off and just I will show you the more clear images formed by this lens. So here is the object. I have just pasted a label over there on the top. Let's see how the image will be. Here is the convex lens and here is the focused image. Here that green label is down. It means the image is inverted, and we have focused that object's image on the screen, so it is a real image, inverted image, and smaller than the object. Next we will decrease the object distance, then the image will be larger but real and inverted. I am changing. I am focusing. Yeah, done. So now you can see real image, inverted image, and larger than before. Now again I am going to reduce and I am going to place the object in between the focal length. Now no image formed on the screen because now this convex lens is acting as a magnifying glass. We can see now. Here upright image, magnified image that is larger than the object, and it is called as virtual image because no image formed on the wall. In simple words, when the object is placed in between the optic center of the lens and the focal length, then the converging lens will act as a magnifying glass. Let me conclude. Images which can be focused on wall, screen are known as real image. The image which can't be focused on any screen or wall are called as virtual image. Hope you enjoyed this lesson. Thank you for watching. Bye bye.